Hey everybody, Matt from Eastwood. We're here in the Eastwood garage doing another live tech session for you guys. Today we're going to be doing a little bit of welding, so if you are interested in learning about welding aluminum, make sure you tune in and stick around. So if you haven't watched one of these before, we try to make it fairly interactive, so you can log on to Facebook or YouTube to watch this broadcast. You can join the chat. And you can ask questions. So as always, we have Scott. Say hello to your fans.
Yep, I'll be sitting here, so if you guys have any questions, make sure you hit me up on YouTube or on Facebook. I'll be able to answer them, or I can always shoot them to Matt as well. So let's see how to use the spool gun.
Cool. So today we are, again, covering the spool gun, as we hinted at yesterday and Scott just mentioned. We get a lot of questions. Pretty much every broadcast I ask you guys to let us know what you'd like to see. And something we get a lot of comments about is how to weld with the spool gun using the MIG Welder. So I'm going to show you guys how to swap everything over and run a couple welds and give you a couple tips that's going to get you going for doing MIG welding with a spool gun on aluminum. So we shot a clip just to make it a little easier so I'm not fumbling around with this, of swapping it over, taking the standard MIG torch off. You just take the plug for the switch, unhook your wire, like so. You can twist it over, and you do lose a little bit of wire because you have to cut it there, and you loosen that one little wing nut there, and then the torch pulls right out. So with the torch pulled right out like that, we can basically just plug this torch right back in here. The connection in the front here, I'll turn this so Joe can get a shot here. So we plug the torch lead back in, and we thread the switch for the finger switch right in. And then I will open this up so you guys can see what's going on the inside here. And I'll turn this for Joe. There we go. So the thing you'll notice here is there's no wire coming through here. The torch lead is fitting in here and tightening down with the wing nut like it did before. But there's no wire coming through here. You actually need the wire to come through the spool gun because aluminum is much softer than steel. And the aluminum, if you try to run it all the way through the lead, what ends up happening is that it will bind or bunch up in the lead, and you'll have inconsistent wire feed, which causes a problem with your welding. There we go. And so what this is this actually has a drive roller in the top here, in there. So the drive roller is actually built into the gun, and when I pull the trigger, it's going to feed through here. On this particular machine, you still adjust your wire speed and your settings on the machine itself. There's nothing on the gun other than the switch to activate the gun to actually feed the wire. So why this is plugged in here and there's no wire, another thing is you have to make sure that this is seated all the way. Because this does flow the gas still through there. So there's gas flowing through and it's coming out the nozzle on the end. So make sure that you have this seated all the way in there before you tighten the wing nut down, and then you're ready to go essentially as far as the gun goes. The only other thing you have to do is right here up at the top, we have a simple little on-off switch. So you flip this over to the spool gun side. What that does is it allows it for the spool gun to work, and it deactivates the drive motor on the inside of here and allows you to actually use it through the spool gun. So I've got that converted over, all set up, ready to go. The other thing here is the shielding gas. So let's see if I can turn this here for you guys. So what we have here, instead of having a mix bottle, we have 100% argon. So when we're welding aluminum, much like we teach you guys when you're welding TIG welding, you want to be using 100% argon. So you do need a separate bottle. If you're looking to MIG weld aluminum with a spool gun, you do need to get a bottle for doing aluminum only with 100% argon. Depending how much welding you're doing, you may be able to get a smaller bottle to get you by just for small jobs. I do turn the flow up a little bit higher on this when we're doing aluminum. Aluminum is a little more finicky. So when I do, here, I'll show you. So I'm going to open the bottle up, turn the machine on for you guys. So I'm going to hit the trigger just to knock the gas down the where it wants to live there. So you'll see I have the gas substantially higher. Usually when we're talking about welding, just standard welding on steel, I have it down around 15 CFH is what I normally do. I have this turned up to a little under, right around 25, so when I go to weld, it's going to drop down to about 20. I want that extra flow of gas so I can get as much coverage as I can. MIG welding aluminum as a process is a little bit more difficult to get a really clean weld than when you're TIG welding, so you need every little bit you can get to help keep your weld clean. So I turn the gas flow up quite a bit higher than I would if I was welding on just regular steel with the gun normally. So that's as far as setting the machine up. Any questions we have so far, Scott, before I get ahead of myself?
Nah, right now they're just, enthralled by watching what you're doing.
Enthralled? Wow. That's a pretty fancy word you used. All right. So next thing that I found, so we get a handful of these. We will get customers that will send these back. And we usually go through every return that we get to make sure that to see if it's whether it's the machine's fault, shipping damage, whatever. A lot of times we get customers that will return an item because they say that the spool gun doesn't work or it won't weld and they're having issues. I want to give you guys a couple tips of mistakes that I've seen beginners make quite often that can cause you to have big issues with welding aluminum. The first and probably most important thing is the stick out of the wire here on the nozzle. So if we were welding, let me turn the wire speed down here. I'm going to cut this down. So if we were welding steel, you kind of want to keep your wire stick out as short as you possibly can. So you could see if we were doing steel, I don't know if you can get in there or not that close. Pretty tough. But for when we're welding aluminum, we want a stick out substantially larger. That's something that if we're welding aluminum, we want it much further. If this was steel, I'd say you got your stick out is far too long. You're going to have an issue. Something right around there, maybe a tiny bit shorter, is actually what you want. With the aluminum, your travel speed is much faster, the wire speed is much faster, and you don't want the wire to actually burn back. So we actually have a little more stick out that's seen on this. So I am welding 3/16 aluminum today. So I have the machine turned up pretty high. I have the wire speed basically maxed out on the machine for welding the 3/16. I want to make sure that it's putting out wire as quick as I possibly can for what we're welding, so I can get a good weld here. So let me pick a piece that's kind of the same. There we go. So just like when we teach aluminum TIG welding, you want to make sure you clean the piece as best as you possibly can. You can wipe it down with our low VOC pre. At the very minimum, it's a good idea to wire brush, get a stainless wire brush that's specifically for aluminum. So that doesn't mean we sell one that's for aluminum, just that you mark it off so that you're not using the wire brush to wire brush, suspension parts that are greasy or even steel. So I'm going to wire brush this until you get a dull aluminum, a dull finish on it. You don't want it to be shiny. All right. And don't forget to ask questions. I'm going to do a little bit of welding. We're going to do some under the hood welding for you guys. So if you want to see what it looks like when you're actually doing it.
Sure. So while you're sitting there cleaning everything up, Matt,
Sure.
One of the questions I got asked would be, with the 135, they can use the same spool gun. Are the settings when it comes to like the stick out and wire speed, having it ramped up, are they going to be very similar?
Yeah, so those settings are going to be the same. No matter that general statement I'm making is for any spool gun. The process of welding with a spool gun on aluminum is the general idea is that you need to turn your wire speed up much higher than you would when you're welding steel, and you also need to have your stick out further out than you normally would when welding steel. So it doesn't matter which machine it is, it doesn't even have to be our brand, it's kind of the same idea. And what happens is a lot of times I've found it's probably the biggest mistake is the stick out's too short. You're doing it like as if you're MIG welding steel, and instantly the wire burns back into the tip of the gun, melts itself right to the tip, and then you're in trouble. You have to actually swap it out and put another tip in. Good question though. All right, so I'm going to do a little T-joint today. And the aluminum wire that comes supplied with our spool gun, you get a free spool with it. It's 0.9 or 0.35 is the size. So make sure that you're using a tip that matches that. That's another thing that I've seen before is people are putting the 0.8 or trying to run the 0.6 tip. So they burn one of the tips up and they try and put another one in. Even though the 0.8 is pretty close, it could actually bind when coming through there, and it can cause an issue with the wire feed. So make sure you're using a 0.9 millimeter, or you're using an 0.35. Same thing, depends how your tips are marked. So I'm going to set this up here. I'm going to put two little tacks on it, and then we'll get going here. All right, so let me tack. Whoop, gotta have a ground cable. All right, so I'm grounded right to the table because we have a nice clean bare metal table, so it'll transfer through. So with how the aluminum melts on the end there, puts a little ball, just like when I talk about doing the spot welding. Same thing, so you want to get that off of there just so you're not having an issue. All right. I'm going to turn that wire speed up just a little bit more. Okay, so we're ready. I got two little tacks there, it's going to hold it. And I'm going to just clamp this onto the table here, and Joe's going to come around and get his little lens set up for you guys. And then I'm going to try and weld around that lens so you guys can actually see what's happening while we're welding. Good? And don't forget to ask questions. If you have some, Scott will throw them out for you.
Go for it.
All right, so see, when I was actually moving the gun, the torch around, much the same as when we're doing steel. You do the little circles, or you come back into your weld just so they overlap. And we'll let Joe come in here. I'll move this piece so you guys can look at it. So what you'll notice, we'll kind of just talk about this a little bit. So what you'll notice is even the little bit of black soot around there, it is very difficult with a spool gun to have zero black soot around the weld when welding aluminum. It's not like TIG welding where it's a little bit dirtier of a process, so you will get a little bit of that. The amount of soot that you get, or black halo around that, a lot of things can change that, so torch angle is really important. Make sure that you don't have your torch angle so that the gun is turned too much at an angle so that the gas is actually flowing away from the weld. You need to make sure it's almost as direct as you can make it while still seeing the weld, so that you don't get soot that's actually, or impurities that are getting right into the weld. And The process when we were doing that, if you ever seen spray transfer, it kind of looks the same when you're doing it, the way that it's melting, because it's melting off so quickly. It looks kind of similar, and you just got to move quite quickly when you're doing this. So I was moving along a little quicker than I would if this was just, you know, a standard steel piece. Any other questions we have?
Sure, we got to go one that kind of relates to what you just did. They ask, were you pushing or pulling the weld?
Right there I was pushing, so I'm left-handed, so I was going left to right, so I was pushing when I was doing that. I've seen a little bit of discussion online and also heard from some guys that that feel that you can do aluminum going the other way. I haven't had much luck with that. Pushing seems to work pretty well for me, and that's what I generally do. But you can play with it either way, what works for you, but I like to push when I'm doing that, so I was going left to right because I'm left-handed. If you're right-handed, obviously, you'll go the other direction. So what I could do to get that little bit of soot off here, just wire brush the weld just a little bit. And it comes right off. But if you're seeing excessive black soot around it, check your gas flow. Make sure you have it turned up a little bit. Make sure that your torch angle isn't too great, or you're not opening up too much. And if you have excessive stick out or the gun's too far away, that can happen. So I'm going to do one more weld. Joe's going to get that under the camera. If you have any additional questions before we end it, please do drop them to Scott, and he will answer them or throw them out to...
Sure. While you're setting up, I can read one more, or actually
great.
two more off to you. They wanted to see, we covered it earlier on, I think, but someone just tuning in, what was the CFH that you have the regulator set at right now for the argon?
Sure. So,
Joe's filming over there.
all right. So I have miscommunication there. Hey, Joe, can you shoot the... So when I normally weld, I have, like if I'm doing steel on MIG, I keep it at about 15 CFH. So we're looking at the red numbers on the center here, on the inside. I keep it at about 15, and then when I weld, it drops down to say 12 or 10. So what I'm doing here is I have it bumped up a little bit, and I have it a little under 25, right around that. So that when I'm welding, it drops down to about 20 when we're actually on the trigger. If you start putting an excessive amount, you're just kind of wasting gas. You can crank it up a little bit more depending what you're doing. But that's kind of where I like to set it. It keeps the gas, I'm not using too much gas, but I'm not getting too much soot in the actual weld either. So.
Sure, and then the other one, while you're still cleaning up, when would you preheat any aluminum before you're welding? I know we've covered that on other videos, but certainly a good topic to talk about.
Preheat's a good question, especially for aluminum. With the preheating, what you may find is if you're welding something that's thicker, that maybe the welder, the amperage of the welder, or even your wire thickness of the wire they're running through there is kind of exceeded. What you could do to kind of help yourself get the proper penetration that you need is you could preheat the part. It really depends on what you're welding with. So we rate this particular machine up to quarter inch aluminum. So I'm running 3/16. I have the machine cranked up pretty darn high. So if I was doing anything that was a structural, or even when I get into quarter, I would probably preheat it, and you could do multiple passes too. So the preheating process, basically what you're doing is you can run an oxyacetylene torch, MAP gas, something like that. You can run that off onto the part, and you can just heat into the actual piece here and into your weld joint and start heating that up. Now you're not trying to get it so hot that it's actually melting the metal. You're just trying to put some heat into it so it's already got heat, so when you start welding, your weld isn't heating the piece up. So that's something you can do. But for what we're doing today, this I don't necessarily need to preheat, but you could do a little bit if you want to help yourself. You just got to make sure that you do a test run if you're going to do that, because you may have to move a little quicker. If the piece already has a lot of heat into it, you may have to move a little quicker. Good one. So I'm going to do another one here so Joe can get that under the lens for anybody that missed it. And if you have any last questions, throw them over to Scott. Appreciate you guys joining in on the chat, as always. So I'm starting on the left here, of course, and I'm going to push to the right. All right. All right. So it does look a little different, and you got to move a lot quicker with it. That's the biggest thing. So if you guys struggle with travel speed with steel, you're really going to have some problem when you start doing aluminum with a MIG, because it has got to really be moving quickly. So this is the other one that we did here. Again, getting a slight little bit of, like I said, the little bit of soot around it, but nothing that's too crazy. You could crank the gas flow up a little bit. You could try and go straight on a little more. I probably would go on a little more straight if we weren't having the camera here on the shoulder. I got to kind of open up for you guys, and that would reduce it a little bit. But you don't want to see a halo that's halfway up your workpiece and off the side there. That's just not good, you know. But this is just a real small one right around the edges there. So I could take this. Back for you guys. Just a quick wire brush takes it right off. So that's the process. Hopefully you guys could see underneath the helmet. The biggest things that I see, probably the biggest mistake is the stick out and the travel speed. Generally, when we talk to customers that have issues with welding with the spool gun, I've found at least that a lot of them is the wire speed's too slow, and they're putting too short of a stick out on the torch, and that's what's causing that issue, burning back onto the tip and having that problem there. Any other questions that we have, Scott?
Sure. One for anyone who's just tuning in. I figured I'll just recover real quick. With the aluminum, you want to use 100% argon as your shielding gas, because we briefly covered that in the beginning, so I figured we'd cover that. Other than that, we're good. We had quite the show, cool. And we actually had a comment that Joe's camera work was really good. We were able to see the circling as you were welding along.
Oh, good. Yeah,
so
Joe's been practicing for a while now. He gets a good pat on the back. He's got these welding shots down.
Yeah, they were able to actually see it. So it's nice to know what you're doing under there, not just see the outcome of it.
Cool. So thank you guys for tuning in as always. For anybody that's local enough here to our Pottstown headquarters, this weekend we have Gene Winfield in town. We're doing a metal fabrication class. It's a 2-day class, Saturday and Sunday. If any of you guys are interested in that, you can call the store. We do have a couple spots left before we close registration that you could join in on the class. Or if you want to just meet Gene Winfield and get an autograph, hang out, hear about his favorite Eastwood tools. We're doing a cruise-in Friday night. That's from 4 till 7, if my memory serves right. So you can come in. It's free. Just come in, hang out. We'll have good deals in the store, and you guys can check that out. So I will be busy with that the rest of this week. So I will catch you guys next week on Tuesday. Thanks for watching. See you later.